Hey everyone, today we're going to cover percent composition. Just like any other lesson, if you have any questions, please make sure that you ask. With that being said, let's go ahead and get started. Let's begin by talking about percent composition. What does it mean? The relative amounts of elements in a compound are expressed as percent composition, or we like to say percent by mass of each element in a compound. All that means is that we're comparing the mass of elements compared to the mass of the compound as a whole. And this can easily be illustrated in a pie chart. We're going to look at the example of potassium chromate. Its formula is K2CrO4. So we know that it's made up of potassium, chromium, and oxygen. Some people make the wrong assumptions and they see that oxygen has the biggest subscript, so it should have the biggest percent composition. But remember, this is percent by mass. In fact, potassium chromate, its mass comes from mostly potassium, which is 40.3% of it. 26.8% of the mass comes from chromium, and 32.9% come from oxygen. Note that all of these percents add up to 100. And one thing to note is that the percent composition of elements in a compound are always going to be the same, whether I have 10 grams of potassium chromate or 110 grams. Now, how do you calculate the percent composition of a compound? Well, there are two different ways. The first is if you're given the masses in the problem. The second way is if you're given the formula. Let's look and see what if we're given the mass. Well, the percent by mass of an element in a compound is the number of grams of the element divided by the number of grams of the compound multiplied by 100%. Note that this 100% is part of the formula. We're just multiplying by 100. And also note this does not count when determining sig figs because it's already part of the equation. So we're going to look at the example. When a 13.60 gram sample of a compound containing magnesium and oxygen is decomposed, 5.40 grams of oxygen is obtained. What is the percent composition of each element in the compound? First, we have to know the mass of the compound and the mass of all the elements that make it up. So when reading this problem, we know that we have a compound that is 13.60 grams, because it states here. And we also know that our compound is made up of magnesium and oxygen, because it says magnesium and oxygen. Now, 5.40 grams of that is my oxygen. And it doesn't give us the magnesium, but if these two have to add up to be my compound, the easiest thing to do is to subtract 13.60 minus 5.40. Note, we went over sig fig rules. When you subtract in scientific notation, it's based on the decimal place. So since both of these numbers go 2 after the decimal, my answer should also be 2 after the decimal when I subtract. And you should get 8.20 grams. Once we found that, we have everything we need to set up the equation. So it says of each element, so I'm going to set up magnesium and oxygen. Now magnesium's mass was 8.20 grams. The total mass was 13.60 multiplied by 100. Oxygen's was 5.40 divided by the 13.60 times 100. When you guys go ahead and solve these out, you get 60.2941176.5, and this one you get 39.7058823.5. However, we have to try to round to the correct number of sig figs. So here I'm going to look at these numbers. I have 3 and 4, so my answer has to go to 3. So 60.3% of magnesium. When we look at this one, this has 3 sig figs, this has 4, so my answer can only have 3, so I can have 39.7% of oxygen. I've always included these for you guys to get extra practice if you guys would like to try to work this one out and see if you can get the correct answer. So you guys can pause this video and I'll put the correct on the next slide. Hopefully you guys got this as your correct answer. Instead of subtracting, we're going to add carbon and hydrogen's mass together to get the compound's mass. From there we divide and we determine sig figs. Note that carbon has 4 sig figs because of our two numbers, while hydrogen only has 3 sig figs. Now we can calculate the percent composition of a compound if we're just given the chemical formula and no mass. And we do this by using the molar mass of each element and the molar mass of the compound as a whole. So the mass of each element divided by the molar mass of the compound, again, times 100. Remember, times 100 does not count towards sig figs at all. We're going to look at an example of propane. It says propane, which is C3H8, is the fuel commonly used in gas grills. It is one of the compounds obtained from petroleum. I want to calculate the percent composition of each element in propane. And the easiest way to do this is to figure out the molar mass. So that's why when I do molar masses, I've always set them up this specific way. I have 3 carbon, I have 8 hydrogen. Carbon number is 12 on the periodic table. Hydrogen's is 1.0079. So when I calculate that, the carbon is going to be 36, while the hydrogen is 8.0632, and my total mass is going to be 44.0962. So note, I have the grams of each compound and the grams of my total now. Then you just set it up just like normal. But first, I kind of want to talk about sig figs. Note here, I have 5 sig figs, 5 sig figs. Here I have 1, 2, 3, 4, 5 sig figs, 5 sig figs. Here we're adding these. So note there's 3 after the decimal, 3 after the decimal. So this should only have 5 sig figs. But we can't round it to the end, so we're going to use this entire number when we do our calculation. So let's do carbon and hydrogen. So carbon is 36.033 divided by our 44 times 100. Hydrogen is going to be our 8.0632 divided by our 44 times 100. And when we solve these, carbon is going to be about 81.714524. And hydrogen is going to be 18.285425. And we have to round to the correct number of sig figs. Note this top one has 5. My bottom one, according to here, should also have 5, so my answer needs to be 5. So 81.715% carbon. If I look over here, my top has 5. My bottom should have 5 based on what I calculated over here. And then so my answer should also have 5. So 18.285%. This one's percent hydrogen. Make sure I label it correctly. Okay. So how do we do? Just like on the last one, here's an example for you to try. Go ahead and pause this video and then check your answer on the next slide. Okay, here's your answer. Please make sure that you're rounding to the correct number of sig figs. This one should have 5 as well as the one down below it. Note 190, this 0 counts because it's at the end and there's a decimal. So, how'd you do? And the last thing is we can use percent composition, since it is percent by mass, to determine the mass of each element in a given mass of a compound. So say I was given 350 grams of water, how much of that is going to be oxygen? Not the percent, but how much mass is oxygen? First, we calculate the percent composition of the element we're trying to find, and then we're going to multiply that by the mass of the compound instead of the 100%. So we're going to look at this example, and it says calculate the mass of carbon and the mass of hydrogen in 82 grams of propane. Now, I found the mass of carbon and hydrogen and the total mass of propane in a few examples back using molar mass. For example, we found that carbon equals 36.033, hydrogen equaled the 8.0632, and my total equaled 44.0962. With that being said, now we can just set it up. Here we have carbon, and here we have hydrogen. Note, we're still going to find our percent composition. So we're still going to take our 36 divided by our total. And then down here, we're going to take our 8 divided by our total. But instead of multiplying by 100 here, we're going to multiply by our mass of our compound. So we're going to multiply by this 82. And when we do that, we get the following answers. Then we have to determine our sig figs. So note here I have 5. This one should have 5. This one, though, has 4. So my answer can only go to 4, 67.01. Down here, this one can only go to 4 because of my 82, so 14.99. And where most people mess up is the unit. Notice we're not calculating percent composition, so it's not a percent sign anymore. Notice we're calculating the mass. So we're going to have grams follow both these, and this is grams of carbon, and this is grams of hydrogen. On the next slide, I have provided you another example. So here, if you want to try it on your own, see how you do, pause this video, and I'll put the answer on the next slide. Okay, how'd you do? Note here, when you get to your final answer, this one is based on 3 sig figs because of my 20.2. So my answer can only go to 3 sig figs. Also note that my unit is now grams because I am finding the mass. And that's the end of today's lesson. Again, any questions, please make sure that you come ask. This is a fast-paced chemistry class, and most of this is review right now, but I want to make sure you're still keeping up with it. Otherwise, I hope you guys have a great day.